Hello. 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 Okay. Okay. Hello. 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 I think IO is a better library to use here, and not FIMT. So FIMT seems to be um, mostly for formatted strings. So I'm going to replace the FIMT.scanf with the IO library. I think it's IO.readline. The Chrome window go. It's here. Um, right, so there's actually a lot of complexity beneath IO. For example, just to read a line, yeah, I'm sure. Yeah, so I've written reading the standard input in C, where you're and I mean it's one of the standard lessons in the C programming language book. I think it's called KNR, and it's a lot more complicated than it actually looks, and it's pretty good that higher level languages today actually help us by abstracting this away. And so read all, I think, is the function to use. I could be wrong. Is it reads from R until an error, or EOF, it returns until the data is read. Until an error or EOF. So we're not looking for EOF. Rather, we're looking for end of line. So I think it's read line. So there doesn't seem to be a read line library method here, which is interesting. There does seem to be EOF. Let's see. Read all, read full. Read. So these are all the names with the word read in them. And that's a lot, of course. Read at least. Read from, read full. Read right, read. I could have sworn there was a read line the last time I had it right, a line of code to read a line of input from the user. Okay, let me just change. I've got to change the category of the stream to be uh, category software and game development. Awesome. Okay, done. Software and game development. Do I show up further up on the top now? Okay, I do. I see that there's a viewer. Is anyone actually watching this? Can you just send a message on the chat window? I can't tell if that's just me or if it's actually someone else watching this. Okay, it's probably just my own computer that's being counted as a viewer. Cool. Okay. Right, I could have sworn there was a readline function, but let's just ask AI what the idiomatic way to read a line in Go is. And yeah, I've switched to Claude. I've been finding that Claude is a lot more high quality than ChatGPT, even though it does take a while for the first token to be sent out. I find the answers to be a lot more pertinent to the question. It handles buffering automatically. What is buffering? Um, Buff.io. Well, yeah, so I remember dealing with buffering a lot in the past. I think it essentially has to do with not wasting system calls and instead buffering either to or from the program in order to minimize the amount of system calls made. And there is and yeah, so minimizing the number of system calls, IO calls, basically. But here, this seems kind of unintuitive because you're creating a new scanner, which is interesting. Read string star. Okay, so I think this is the idiomatic way. Or this could be the idiomatic way. So create a new scanner. Oh, I'm sorry, that's buff.io. So that's the buffer.io package. However, one question I do have is if this function is found in buff.io, why isn't it found in just IO? I think this isn't it operating systems os.readline os. Oh, so this does not have search suggestions. Reader, read file. Okay, that's read file, of course. Okay. All right, I'm just going to use this for the sake of moving on. With the full awareness that this could be wrong, I don't want to trust AI too much, of course. I don't want to trust AI too much because it's it outputs very confident sounding answers, even while it's sometimes being wrong. So, scanner. And so this notation, so the walrus operator is used to declare and initialize a variable at the same time. So os.stdin, so that is the stream, that is the standard input. And yeah, so I found the default boilerplate code to be interesting. Here, they seem to be printing out to standard output, which is okay, but in that case, why not just use print.printf, because the default stream to print to is standard output anyway. So, yeah, I just found that a bit odd, and I wonder what the reason for that is. So scanf, let's not do scanf. Let's instead do whatever Claude thinks the idiomatic way to read a line in Python is scanner.scan. Okay, scanner.scan, interesting. So I think this method starts to read or sets up the standard input for reading. However, what kind of setup would be needed? So let's actually look at how buff.io works. Offered.io, type reader. Perfect. Let's actually use a reader instead, not a scanner, because I think this has readLine. Is a low-level line reading primitive. Most callers should use read bytes or read string instead of, or use a scanner. Interesting. Scanner provides a convenient interface for reading data, such as a file of new line delimited lines of text. Okay. Successive calls to scanner will step through the tokens of a file, skipping the bytes between the tokens. The specification of a token is defined by a split function of type splitfunc. The default split function breaks the input into lines with the terminations stripped. Scanner.split functions are defined in this package for scanning a file into lines, bytes, UTF-8 encoded rooms, and space delimited words. The client may instead provide a custom split function. All right, that's a lot of text, but example lines perfect. Here we go. For scanner.scan, println will add back the final. Cool. So this returns, right, this returns true, I assume, as long as there is text to be read. And then scanner.text returns the next line. Cool. So I think that's what we can do. So for scanner.scan, so scanner.text gives us the input. Oops. Returns the most recent token generated as a newly allocated string holding its bytes. Returns the scanner to the next token, which will then be available through the scanner.bytes or scanner.text method. So bytes returns a byte array or a byte slice, and text returns a string. However, how do I set the default split token? So I need to set that to be the new line character. Split func. Interesting. So here, I'm not sure. So here, I think token is the delimiter. Will step through the tokens of a file, skipping the bytes between the tokens. Skipping the bytes between the tokens. Will step through the tokens of a file. What's token here? Skipping the bytes between the tokens. So token is probably not the delimiter, because if I were to skip the bytes between the tokens, then I wouldn't get what I need. The specification of a token is defined by a split function of type splitfunc. The default split function breaks the input into lines with line terminations stripped. Okay. It advances, which will then be available through, advances the scanner to the next token. Yeah, I mean, I think it's the documentation here is a bit problematic. I think this is going to work, but yeah, I feel like the documentation could be better. Anyway, let's run. Oops. Oh. Films.f print. Oh, apologies. So I want to do a right. So here, what's happening is that I'm scanning the input before I'm outputting the prompt. So I'm gonna have to. What I've got to do here is I've got to scan the input after. After the prompt is printed. So what I can do is I can say if scanner.scan. So I think it returns a false if either there is no input or there's an error. So break. I think this should work. Right, okay, this works. So scanner, using a scanner seems to be the idiomatic way to read a line and go. And the next part here, we're going to print read. Yeah, so here we're just implementing, so a REPL is a read eval print loop. Basically, it reads user input, it evaluates what the input should output, it prints the output, and then it loops back and prints the prompt again so that the user can enter an input again. So I think we should look, we've implemented a REPL. So here I think what I've learned is the idiomatic way to read a line in Go. So we're supposed to use the buff.io library and use a scanner from the buff.io library. I don't know why that is, but sure, I'll look into it if I ever need to in the future. But it does seem to be idiomatic from what I've seen in the documentation, from how the documentation seems to document the methods in the library, the package. Yeah, so that's actually one of the best things about Go. I think that the documentation is really accessible. Here, so the documentation is actually part of the source code itself. And if you want to, you can actually look at the source code of Scan if the documentation is unclear. So the source code and the documentation are like tied together very closely. And here, for example, yeah, so pressing scan takes me into the source code, and this is the actual source code of the Go programming language. This is the standard library, of course. But there are actually many times where I've had to look at the source code because the documentation was unclear. And yeah, I think that the ecosystem in Go is very good compared to languages such as, say, Python, where you typically have a separate documentation website. You have read the docs, which is and it's separate, and then the source code is kind of separate, and this is a lot better, I feel. And I think this is probably something that can be implemented in other languages as well. Cool. So we've implemented a REPL. Let me charge my laptop. Okay, so next we're going to implement the exit built-in. And yeah, so built-ins are commands that the shell natively understands. It's not among the programs that are in the path directory. So essentially, it's a built-in command, and cd, for example, is another example of a built-in command. So we're going to be implementing the exit built-in. Let's do that. So I think this is going to be very simple. We're just going to check if, oops. We're just going to check if the input is exit, and if it is exit, we exit. We end the program by calling os.exit and passing a return code. Okay, so I think there are different ways to. I think maybe we can use a switch case. It's been quite a long time since I actually wrote Go, so I'm kind of rusty. I think it's switch input. Let me just read the stage anyway. In this stage, we'll implement the exit built-in is a special command that terminates the shell. It should terminate immediately. We'll then send an invalid command followed by the exit command. Cool. So case exit. I think the exit method in the OS library calls the exit Linux system call. And by default, we want to print command not found. Yeah, this is already a lot cleaner than the Python version where I had to use a if-else condition. Oh, hey Archit, are you here? Why don't you create an account and we can chat here. Can you hear me? Cool. So I think this should work, unless I've got the syntax here wrong. Hello. There we go. This actually does work, which is awesome. So I remember there was another type switch syntax available in Go, but that's for dynamically viewing the type of a particular variable during execution. I think that's known as a type switch. I think, yeah, in this stream, I'm probably just going to go over the Go tour once again, just to recap just to dust off my old Go knowledge. Cool. I think this should be it. Implement exit. Okay. Oops. And this shouldn't work. Cool, this works. All right, let's move on to the next stage, implement echo. In this stage, we'll implement the echo built-in. The echo built-in prints its arguments to std out with spaces between them and a new line at the end. Echo hello world, and you have it prints its arguments, and Cool. So one thing to note here is that even if there is a lot of space between hello and world, it's going to be counted as two different arguments. So we're going to squash the number of spaces to one. Unless, of course, we put this in a string, and if we put this in a string, we're going to have to consider the entire text in the string as a single argument. And they have a note about print here. Okay, so here input is not quite the input. We're gonna have to actually split the input string on white space, and the first member of that list is actually our command itself, which could be a built-in or it could be an external program. But I shouldn't be just splitting on white space, because if I just split on white space, then I'm not going to be able to account for quotes. Because say I have something like echo, hello world, which I think we will implement in the future. I think it's one of the stages here. It's under the quoting module. If I split on white space, then we're gonna have our list that looks like so, which is not what we want. So we're gonna have to actually write our own splitting function. I think when I implemented the Python version of this, that's what I did. I wrote my own splitting function. So we're gonna have to parse it ourselves. I don't think there's a simple way to do it, but I think for this particular stage, we can get away with just splitting on new line and considering the first argument as the command. Considering the first member is the command. Implement type, locate executable files, run a program. Right. Okay, so here I think the test cases are actually pretty simple. The test cases themselves don't actually have more than one space, so we can actually just split the input. So that's the raw input. Split input equals strings.split input, and we want to split on any whitespace character, which I think the strings package does provide. Let's go to the top. I would have assumed there would be a keyboard shortcut to jump to the top, but of course I could probably use home. Anyway, strings, it's going to help us split a string on split characters, split, separator. And I think separator can actually be a list of many strings. Um, but there's also something trim space. Right, so I'm just gonna split on the space character. That's gonna be the split input. And as far as I remember, Go does use Pascal camel case or Pascal case if the name is exported. So now we're gonna actually split on, or rather switch on split input. And so let's create a new string. Case exit. And if it's echo, we're gonna print all of the split. And this is, of course, assuming that there are greater than one number of arguments. Yep. Oops. So I've got to import the strings package. Cool. But I've got to add a new line here, of course. And I think this is going to be nil, and it's not going to be a problem. Okay. It's going to print a new line at the end. Let's exit. Okay, that works. So we've implemented the echo built in. Okay. Yeah, this is already a lot more fun than Python, for sure. Uh, Even though it does seem verbose, it seems, I don't know, a lot more. Uh, yeah, it just seems better. I'm not sure if it's preference or it's objectively easier to understand. But having types in a language really makes things easier for me to, um, at least at least when I'm implementing a shell, for example. Anyhow, let's move on to the next stage. Implement type. So what type does is that it's another built-in. So the first argument of type is the command that you want to know the type of. So if you say type echo, it's going to say built in because echo is not an external program, rather it's a built-in. But if, for example, you specify a command that does not exist, it's going to say not found. But for now, since we have not implemented locate executable files, we're not going to. We're going to print command not found by default if it's not echo or exit. The type built-in is used to determine how a command would be interpreted if it were used. It checks whether a command is a built-in, an executable file, or unrecognized. For example, type echo, echo is a shell built-in, type exit. Built-in commands print, so type itself is a shell built-in, of course, because it's a shell built-in. For unrecognized commands that don't match any built-in, print the command that the user passed to type, followed by not found. We'll handle executable files in later stages. Okay, let's do that. So, if we have type, we're gonna have another switch here. And this is, of course, assuming that split input is greater than 1, the length is greater than 2. Should we account for that right away, or should we do that later? Well, yeah, I think for now we can just keep it. We can just keep things simple and not consider the case where the user inputs an invalid command. Oops, that's Python syntax. Case. So if it's, I think we can actually case exit, echo, or type. I think we're allowed to group. In Go, we're allowed to group cases this way using a comma, which is going to say printf is a shell built-in. And so because these are built-in functions, ideally I would assume that these should be programmatically, these should be variables instead. Just I think that's better programming practice, but we're printing a new line after that, but by default, we're going to say command not found, and I think, oops, it's the same as this. YY is to yank it, is to copy it. But we don't say command not found. Instead, we say not found, which is interesting. Sure. Nice. Oops. Type say shell built-in, type echo. Cool. Exit. Awesome. Now let's try CD, which we have not implemented. CD not found. Awesome. So I think that should work. Oops. Of course, yeah. Clear doesn't work. Let's type exit. Git implement type git push. Cool. That seems to work. And yeah, so the next one is pretty interesting. Locate executable files. I think implementing CD would be pretty interesting, actually. Okay, but before I move on, I actually want to change the prompt. I feel as though the prompt looks very childish here, especially with the color of my terminal background. So I find red to be soothing. However, this doesn't seem to be going well with red. So I'm gonna have to change the prompt to something more suitable, but something that distinctifies it, that distinguishes it from the output of the command. Or let me, for now, actually not use any colors at all. Yeah, I would be happier with no colors rather than a childish looking prompt. Oops, there is a problem. All right. This is a lot better for sure. I'd rather have no colors at all than a childish color. Okay. Let's move on. Locate executable files. Yeah, honestly, I should. Hmm. Sorry. Mm. And I'm actually gonna not have the dog. One moment. Okay. Great. I've turned off the syntax. This is a lot better now. Yeah, and I'm actually new to Mac OS, and I'm really not sure why or where I can change the PS1, the prompt here, because I don't want these colors. Um, but it seems, uh, yeah, it just seems kind of bizarre because it seems like you need a you need the colors mod. You need to oh, okay. So colors is actually a function, is a ZSH function, and but why isn't it called by default? I would assume that it was because I didn't make any changes to my Z profile, which is interesting. PG, FG, types. Okay, I don't understand this. Yeah, the terminal colors are like a topic in and of themselves, and probably look into it later. But for now, say it's there. There is no colors off. Unload. Auto load. Is there a way to unload colors and kind of reverse whatever colors did? But it kind of does make sense to have colors, but what's bothering me is why exactly was colors off in the first place on my default macOS installation? Let's actually use AI to Yes, I know that macOS switched to ZSH since it ran into licensing issues with Bash, but yeah, it's really annoying how ZSH uses Z profile instead of I don't know, using xcg homedir, which is like .config in the home directory, and inside which ZSH can create a folder for itself to store its configuration files. So I know that that's the XDG specification, and I'm not sure if, of course, all Unix-based systems adhere by it, but most Linux applications do. And I think it would be neat and uniform if macOS did that too. Okay, so what's the problem here? So the problem is on my default Mac OS terminal, it seems like colors are turned off. Why is that? It seems like colors are turned off. Why is that? On macOS, the default terminal does support colors, but there are a few common reasons why you might not be seeing them. So this is something that I don't actually understand, why term controls any of this, because I would assume it's right. So whatever's printed as standard output, whatever encoding it is, that I think if it's not color, you're not supposed to write color encodings or symbols that control the color, I suppose. That declares itself as supporting ANSI colors. I don't know what ANSI is, but I've seen it very often. If you're using ZSH, colors should work out of the box. If you're using Bash, you might need to enable them explicitly in your configuration file. Okay, let me... First of all, I shouldn't be changing the profile because I think this applies to all users, but why is the profile file in my home directory? It's bizarre. Just gonna actually... Let's quit the terminal and open it back up. Here we go. So this is interesting. So it seems like macOS by default does not support colors. Or, I'm sorry, the terminal app on macOS does not automatically support colors. But if I do auto load, apologies, colors, and then type colors. Oh, interesting. Oh, let's try that again. So, would oh, okay. Right, so I think what's happening here is this PS1 here automatically includes colors. So ampersand n automatically includes colors. Right, so it's not actually a problem with macOS, with the terminal app per se. What is %n in ZSH? That expands to your username. Well, is it colored by default? It displays as interesting. If it's not colored by default, why would this color it? So this does not color it. So this is not colored. Then why did it show up as colored the last time? Gosh. I don't want to be modifying Z profile. This is annoying. This is quite annoying. Hold on a second. Is it because percentage n comes with a default color set? By any chance? Bold color. Okay. Foreground. Resume support. Okay. So this seems to be CSH code for specifically for terminal, for the terminal application. There's the whole thing about login shells and interactive shells. Gosh. Every terminal window is a login shell anyway. Okay. I'm not going to look into this. I feel like this is way more complicated than it should be. Let me actually quit the terminal. Cool. Okay. let's actually get back to executable files. At some point, I'm going to have to look into this whole login shell and interactive shell uh, distinction and try to understand the difference. But I feel as though there are too many configuration files, and there should just be one. Yeah, just so complicated, and especially since CSH is supposed to be an improvement over Bash, or maybe not. Fish, for example, is supposed to be something that is built for actual terminal usage, as opposed to being used as a scripting language. But sure. All right, let's start. This stage, locate executable files. In this stage, you'll extend the type built in to search for executable files using path. The path environment variable specifies a list of directories where the shell should look for executable programs. Okay. When tech receives a command input, your shell must follow these steps. This is a lot of work. Hey, do you hear me now? Okay, let's move on to executables. So by default, I want to go through the path environment variable and check for whether or not the command that the user has passed a type exists in one of the path directories and is an executable. So I think for type, it might be useful to actually move everything over to another function. But for now, I think I'm just gonna enter the logic here. So first, I've got to get the environment variable. I think it's os.getEnv. Path. So that's going to give me the value of the path environment variable. And I'm going to have to... It is possible that it's empty, though. So let's look at the documentation. Interesting. So get end, so the E is not capitalized. Is it Pascal or Pascal? Pascal case. Pascal, but I would have assumed in Pascal, because Go follows Pascal case, E would be uppercased. Retrieves and returns the value, and which will be empty. Awesome. So there's a difference between an unset value and an empty value. Use lookup environment. Okay, so I think we don't actually require another variable to store the path environment variable in. So we're going to have to split the path environment variable on the path separators. I think it's path sep. So path separator is OS specified path separator. I think this is different. I think we're looking for path list separator. Path separator. Path list separator. I think this is actually ambiguous. So let's look at the source code and see. So I think Windows, for example, uses... Yeah, okay, so Linux uses colons, but I think Windows uses another separator. Path Windows, for example. There we go. Yeah, so we're actually looking for a pathless separator. Yeah, this is another very interesting thing about Go. So it kind of hard codes operating system names into the source code, into the source file name itself. And when you're compiling for Windows, it ignores underscore Unix files, which is somewhat bizarre because one would have expected it to be a configuration to the build command rather than something hard-coded into the file name. And likewise with public and private. So Go doesn't really have a public keyword in order to make a name in a package accessible to other packages. But instead, if it's camel case, it's not public. But if it's Pascal or Pascal case, it is public. So Go is a little different in that way. It's pathless separator, but sure, pathless separator. So I think here, separator, is that the right spelling? I think so. Okay, so so these are the directories, and I'm gonna split on the directories. And now I need to go through each of the directories and get a list of all the files in those directories. So first, let's go through each of those directories. So how do I go through each of these directories? Variant dirs. That's what I would do in Python. But in Go, I don't think we have the in keyword for iteration. So how can I forget this? How do I iterate through a list of strings and go? Dir and dirs. I mean, of course, I could just write a very straightforward loop loop statement. But there should be an easier way. I think it's range. Idiomatic way to loop through elements of a slice or an array and go. I'm pretty sure it's not I. Ah, there we go. Perfect. Range. So if you do not want the value, discard the index. Only index. Traditional. Right. So you can either you can also have a traditional loop where you have the precondition, where you have the index, the precondition. I'm sorry. The pre-initialization short statement, the condition, the loop condition, and the post statement. The pre-statement, the condition, followed by the post statement. Cool. Let's now do this. So I do not actually require the index. Okay. So now that I have the directory, and I need to get a list of all the files in that directory. I'm sure the OS package has a method to get a list of files in a particular directory. Let's have a look at it. Dir entry is reader recent in directories, returning all of its directory entries sorted by file name. If an error occurs reading the directory, reader returns the entry to read before the error, along with the error. So for now, I'm just going to ignore the error and I'm going to go through each dir entry. Oof. Okay. And it's an interface, so I can get the name, whether or not it's a directory, and then I can get the field info. And I suppose the field file info is where we get whether or not it is an executable. File mode. So let's see where we have executable, whether the current user can execute that file. DSA directory, append, exclusive use. Interesting. So I'm going to have to use file mode But it is possible that another user, it is possible that I've got to look at another set of bits for a particular user because another user owns the file. But it does seem to have methods as well. Is regular, it describes the irregular file. There is no mode type bits are set. Type, file mode, permissions, is there. Interesting. Yeah, so one thought that comes to mind is that there's a lot of allocation that happens here. So in Python, there was not a lot of allocation in the sense that whatever was returned was exactly what I asked for. However, here it seems like we're allocating a bunch of like additional memory for information about the file. But I can't. But are any of these dynamic? I don't think so. Are we actually opening up any resources on the operating system? That's something to consider, I think. Okay, let's get to the executable part later. We can actually start by going through each of the entries. If not entry.isDir, so entry is a dir. It is a value that satisfies the interface dir entry, and if I actually not just whether or not it's a directory, but it could be another kind of file. It could be, so since in Unix everything is a file. I don't want a socket to be included in our consideration in our processing of executables. So let's actually extract file info. I think that's what we need. There we go. So this returns a file info only when it's called, which is interesting. So I don't think memory is being, we're opening up any resources here. So entry.info. Again, we're going to be ignoring the errors. So now we can go to file info, which is another interface. We can go to mode, is regular file. Oh, interesting. So a directory is not a regular file. So I'm looking for a regular file. Interesting. So a directory itself is an irregular file. Socket device named pipe symlink char device. Okay. So I'm gonna get the mode. Mode equals, again, we can be errors if any. What would the implications of ignoring errors would be? Just exponentially grows in complexity. Because when there's an error and we ignore it, the next thing is going to error out too, and then the thing after that. So info dot mode. Um, right. So um, I think is regular is a lot better than checking whether or not it's a directory, because even if it's not a regular file, it could be um, I don't know, a named pipe, for example. Even if it's not a directory, doesn't mean that it's an executable file. So I really need to check if it's a regular file. If it's not a regular file, then signal. But otherwise, uh, otherwise we're gonna have to check if the file is executable, and we are gonna get that from the mode. Uh, maybe not. Represents a file mode and permission bits. So I think testing whether or not the file is executable is not as easy as just looking at the file mode and checking if the executable bit is set, because we're supposed to actually look at the current user and whether what if the current user is actually part of a group that can execute the file. And yeah, I feel as though there are a lot of, I believe it is more complex than it looks. So is it possible that the operating system provides an abstraction for this, a system call that checks whether the current user is able to execute a particular file? So I think we can try to go to OS. And I think that it is possible because of how complicated it is, or how complex it is. It is possible that the OS provides some kind of abstraction to check whether or not a file is executable. File descriptor. Okay, and read stat returns a file info. Okay. So I think stat returns information about the file and not doesn't check whether or not it's executable per se. Let's actually just take a look at stat. I don't think it's going to be helpful, but let's look at it anyway. File info, and this is again okay. This is taking us back to file system. Is it possible that Go somehow returns whether or not it's executable? Is regular mode perm? Hmm. Can you still hear me though? Oh, okay, cool. Okay, so I think okay, let me just explain what I'm trying to do here. Uh, so given a particular file, so even if I get its mode bits, for example, from here, uh, I actually don't have the context for whether or not the current user is able to execute the file, because that logic would actually be kind of more complex than what this task probably wants us to do, because it is possible that the current user belongs to a Linux group that has the permissions to execute the file because of so it's user group others. That's how mode bits are structured on Linux. Um, right, there seems to be some sort of spam with the chat. Let me get it. Um, I think I'm just gonna ignore the bot in the chat. Okay. So yeah, so I think I'm just gonna ask Claude for what the idiomatic way to check if a particular file is executable by the current user in Go is. Claude in Go, what's the idiomatic way to check if the current user can execute a file? Can execute a file. Exactly. However, this only checks if the executable bit is set and not whether the current user specifically can access it. Info.sys.stat. This gets complex quickly. Yeah, so we're going to have to use, so since this, we know that it's going to be run on Unix, we're going to have to use this library. But this is part of the testing libraries. This is part of the X standard libraries. So we're not going to be able to, I don't think we're actually going to use that. And how did I do it in Python though? Why was it so easy in Python? Um, excuse me. There we go. os.access file path and XOK. So it seems like Python has kind of abstracted away the complexity for us. Right. But it's a lot more difficult than Go. But I think it's good that I spotted the complexity here. It's not as easy as just checking. Most language. Ah, there we go. os.access path in Python or files.is executable in Java. but Go does not. Yeah, this kind of makes sense. 0, 1, 1, 1. Int 32. It's 8 bits. 3, 3, 3. 3 bits each. Okay, I'm gonna have to take a break actually. This is a lot of things. This is a lot to digest.